Alright. Looks like we're good here to go. Let me just make sure everything's good. Yeah, the microphone's fine. Alright, let's see. Alright, there we go. Let's see if the audio's good. There we go. Alright, yeah, it seems to be fine. Audio seems to be fine. Let's put it in the chat. I should probably make roles and stuff in this channel. You know. Okay, everything looks good. I think. Let's go back. Alright, get rid of that. Most things seem to be set up. Let's see. Give me a couple more seconds. Set up a paint tab. We might need it. We usually do need one, so let's keep that. What else? Obsidian. And the actual page. Alright, let's see. Did I update everything correctly on here? Yeah. Everything's updated. Looks like everything's updated, so that's good. Oh, I need to change some of this. I forgot to change this stuff. Like adding as I go. But yeah. I will change that after. But last time we left off on the parser. We actually finished the parser. We can actually kind of make sure everything's okay before we move on. Let's just do a couple of little things. I already tested it fully. Let's just make sure nothing broke. I did make a couple little refactors here and there. And let's do like, just like, if x equals y. Just add some random variables in here. Let's do float. Block statement. Yeah, looks like the parser's working fine. What else? What else kind of tests did we have? What else should we test before we move on? Let's test like a function call. Let's see. We could probably do like and then the amount of arguments we have. We can say x, y, z, and that's how a function should be written. Or, well, I guess no. We need the semicolon. Yeah, so it classifies an expression statement and a function call in specific. And then the arguments are the one specified in there. Maybe we can do like a little while loop. We'll say like x is not equal to 3. Well, I don't have plus plus in here yet, so we're gonna have to do x equals x plus 1. That's what we're gonna have to do. Should work. Let me just check while. Binary operation works too. Yeah, it seems like everything is working. Okay, that's good. Everything's working directly in place. So now we're on intermediate representation. It's going to be quite interesting to see how we can actually implement this. So basically, let me just kind of set up an example that we have. Let's go into Obsidian. So we need like a bridge between the abstract syntax tree that we generated, the 3D abstract syntax tree, and also the next stage, which is the code gen, which we will then bridge the gap between assembly and our front end. But to make it easier for ourselves to be able to do that without having to worry about the format, we will make a format that is very easy for the risc-v assembly to be mapped to. And that's going to be our 3 address code with this. Our 3 address code with our IR. That's what we're basically trying to do right now. So essentially we have something like this. A destination is equal to T1 plus T2. That's very similar to assembly, where we have our add instruction here, our destination register, our source register source 1, and source register 2. So that's what we're trying to basically map out what we have right now to be this. So each of these fields that we have, so we have our destination register, our source registers, our 2 source registers, and we have our operator. We can say that those make up a quad. And a quad will just basically hold each of these separate values that we can use. So what we need in a quad is these 4 elements. So we need let me just look it right now. So we need, let's say we have something like I don't know, we'll say like x is equal to 1. Two times 3. Or we'll use that example later on, probably. Let's just use our main example here. So we have T3 that we had, T3, T1 plus T2. X3, X2, X1, I believe, or X1, X2. Yeah, so you can have this up here and kind of move off of. So we can say this is our, we can say that this is our destination. Oh, we can type it out. Our destination register. Then we have our 2, well, we have our 2 source registers here. So we'll say this, we'll say like this. Bear with me, guys. I'm trying to think about it as we go. so it might be slow, but so we have slowest register, which will be these two. And we also have our operand, which will be, let's call it operand. And this essentially makes up our quads. So we can probably go in here. Let's just make a file in the shared path. Say, let's call it ir. Not i.h. ir.h. 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 Looks like that's good. And okay, what do we actually need from here? We don't really need, this is just going to be like our definitions. We don't really need any includes from the previous, so I'll probably just say, as usual, private ones, and we'll probably say, do we need IOStream or vector? We're gonna need vector, for sure. We're gonna need vector, so let's say include vector. I don't know if we need IOStream, so let's keep that off for now. I know we need include vector for sure, so let's do... Okay, so we're gonna need quads. Enum of quads here, which will store our destination register, source 1 and 2, and our operator too. We can just say these are operands, but we want to make it as close as possible to our actual assembly. So we're gonna need an enum of quads, or not an enum of quads, a struct of quads, sorry. A struct of our quads. So we can represent that map, and we can say, we're likely gonna need to going to need to distinguish between these. So we can probably do like a struct of just like our operand types, maybe. We can do like a struct of operands. So we can actually define what our operand is. We can probably do enum of operand type. Enum of operand type. And then we also want to map out what our operator will be, which we will likely have an enum of our, basically our risc-v assembly mappings. That was good, Ghost. What's up, Ghost? What happened, bro? So struct of quads. All right, so let's try and write that out. Well, first we probably want to say struct of quad. And in here we'll have our different types, but first we probably need to set up our operands. Nothing much, Ghost, just good to be back here. What's up, Isrith? Doing the intermediate representation of the compiler right now. So we can say a struct for our operand, so we can define what our operand will be. And we can probably say the operand will consist of the operand's type that we want to define, operand's type, and also an ID value so we can access as we need. So probably say we'll set like an enumeration of different operand types. So let's say operand type. And what are the different operand types that we can have? What is risc-v? It's a CPU architecture, just like ARM, x86, MIPS. It's a completely open source architecture. My lang is compiled out of libprintf and main and my custom Lego system. I'm making a linker because GCC or Clang is not my style. Oh, you have the backend too, Ghost? Alright, different types of operands that we can have. We can have alright, so let's just kind of just think about it. So we can have, based on the different types of instructions, we can store stuff in a register. Let's low-key pull up like risc-v, like a mapping of it. We're able to store them in registers themselves. We also have the ability to access immediate values themselves. So like a value like 4 or 5 just by itself. We also do have our labels here. We can jump, so these are for our if statements, else statements, function calls for jumping to a different place within the code, so we can have those. So let's say like, okay, so we need virtual registers, immediate values. Oh, okay, LLVM automatically does that for you. Interesting. Vreg, immediate. We can probably say like label. That's what I wanted to say. Yeah, label. And we can just set like a random enumeration just for like none. If it's not there, if we can't identify it. So that should be fine. And we probably want to set, now we want to set our, okay, now we can actually set up our operand here. So we want to set our operand to be operand type, and operand type. And we'll just like initialize it right now as a non value that we have. And we also want an int value that we can set to access. And I said I was lazy, and I am, but LLVM does not do linkers, so I make it myself. Interesting. I might have to make a linker myself too then, probably. At some point. Playing on bootstrapping? Interesting. Okay, so now we need a struct for the quad, so we can probably say like, okay, so we need our destination register, source register 1. So we'll say that we have operand and okay, so we want to say, let's just say like source 1 to represent source register 1, and we can also do the same for source register 2 as well. And we can say, okay, we do need to make our mappings for the operator, so we can know what operator to use. We can also say operand for destination register, because that would be an operand that we're storing it into. And let's say, okay, let's make a mapping here. Let's call it IR op, or let's just say it like that. And then, so what? Let's do a certain subset of them right now. Let's do add, subtract, and multiply, and division. For now, we'll just have these. We'll add more later as we go on and expand. Okay, that should work. So now we can probably do IR op, and we can just set it as operand, and yeah, that should work. That should work, but okay, so we have our quad that represents the equation, the value that we need, the values. Yeah, I think we're good to move on to the next part. So now we actually want to set up the IR, the actual IR generator properly. So let's make some files here. IR generator.h, and let's make a CPP as well. IR generator.cpp, and let's implement these two files. So let's see. So this is where we need to walk the AST that we have. We need to walk the AST and we can take in either our expression visitor or our statement visitor and walk the certain ASTs that we need. Okay, one thing we do need to change though is that we need the visitor. These need to be int now, because we need to return proper int value to put into our to set up our virtual registers. These can be void though, since they're just behavior. This is actually returning something. The one bad thing is I cannot print strings. I'm adding that though. Interesting, interesting. I'm surprised you got the whole thing finished. So let's say track once. Let's say, what should we include? So let's include our certain headers. We're going to need for sure our AST. Absolutely, we're going to need our visitor. And also our IR as well. We should need our IR. It should be shared, so we have to do... What's the way to do that again? It's like slash... Is it this slash or larger slash? Hold up, let me check. Where do we have it in? We have it here, I believe. Or I guess not. Where did we actually include that? In here, shared. Okay, shared slash. Okay, yeah, that's the fast path. So shared slash RNH. That should work. It is 1500 lines of code to make a script that can make a var and print the var and return a number like. Module main, function main, i32, and let x i32 equals 10, print x for 0. That's interesting. It's very similar to Rust syntax, it looks like. I don't understand Rust syntax, but it's very similar. Okay, let's probably make a class. We'll call it IR generator, and we want to be taking these two, so we can lock them. So we'll publicly inherit from both of those. We'll say public expression visitor and also our statement visitor. Or I think we just do this and then statement visitor. Yeah, okay, that works. And then set the classes, so we do want to keep a track of our virtual registers that we have. We don't want any virtual registers to collide, but we can have an infinite amount of virtual registers, so you're likely set up some rules. Rust, it would be fn function main 32 let x equals 10 print ln of that x turn 0. Yeah, dang, it's very similar. What's the point of the ampersand? Is that going to be a reference? Alright, let's call it like int vreg counter. So we'll have a vreg counter and we'll say set that as 0. Or I guess let's not say 0, let's say 1. Let's just set it up as 1. We'll set our first vreg, our first virtual register as 1. And what else do we need? So So we'll definitely need a vector of quads to basically give us all the instructions that we have. So we'll say student vector, and I need to include that. Include vector. So student vector. And we'll say it's of quads. And we'll say instructions. We also need some functions like, we need some functions to allocate our vreg, so I want to say allocate we'll see that in public, so we'll set so we need a way to increment this. We need a function to increment this, and we also need a function to actually take in each quad that we operate on. So okay, so we can probably set up two functions within here. I mean, I guess they can be public, I guess. I mean, private. So we could say it's allocate vreg. We'll implement that when we get there. Your language has 20 keywords. Yeah, I think you told me about the keywords are. The and is just so I do not look at it like a copy of Rust and it looks cool. There's a ampersand in my language that can be out like memory, change variable types, etc. What's up, EXO? Made some cookies, almost used the whole box. Nice, man, nice. We probably do want another function as well. Essentially just to like emit our quads, that's what the term is. And it's just gonna be IR op that we had. Let's check back in here. Destination, operator source 1, operand source 2. So we can probably do that. And also, let's see what else we need. Well, okay, we'll probably do it as we go. So let's probably try and implement the stuff in CVP. Let's include our IR generator, H, and probably say like vector string. Okay, we're gonna need to implement these helper functions. Let's do that real quick because I have these in my mind. Should be IR generator. Okay, vreg. Yeah, I do know what IR does. We're basically bridging our front end and also our back end, making it easier to bridge that gap between the assembly, like how the assembly is working, how it's written, and the front end. So essentially we're just walking the 3D AST, the abstract syntax tree that we have, and then we're making it just a flat list. You're making a type checker? Maybe. I might be. Okay, allocate vreg, so we just want to return. All this is just basically returning our vreg counter. We're returning our current vreg counters, so we set our current one and then we increment by 1 so that the next one can be using the next value. Let's see, what next? Emit. Alright, for the emit one, what's up, slow? Stumbled upon the concept of IR when making SDK generated for Unreal Engine 3 game. That's nice, man. That's nice. I didn't realize that SDK generator will also need one too, but that makes sense though. Yeah, idea of IR is very interesting. It's very complicated though, I feel like. But I guess I'll get better as I implement it. What's up, Samiator? Cool code sesh. I appreciate it, man. I appreciate it. Alright, so emitting it will just be I'll take a look. Take a look, XO. Dang, why are they like crushed together? They didn't spread out properly. Might taste good though. Might taste good though. But that's interesting. All right. Okay. We're just gonna be taking our quad. We're just gonna be taking our quad that we have. And we essentially just want to push back all those values onto our list that we had in here. So we'll probably say instructions pushback. Okay, let's use the same pattern that we use for all of our private member variables that we usually do. Pushback. And we'll say we'll just push back all these values, I guess you could say that. We'll just push back all these separate values onto the vector. probably set it like this. Maybe we should just probably not do this. We might as well probably just make a quad itself, probably. Actually, make a lane, you should make LSP. What is LSP? I've heard about it, I just don't know what it is. So we'll just say like quad reference. And just say quad, so we can just take that in. That'll probably be better, to be honest. Better way of doing that. Void our generator emit. Oh yeah, we need to change this. Let's also put that in here as well. Okay, that should be better. LSP gives editor support for your language. Interesting. Yeah, I might make that then, probably. Okay, so okay, that should work. What's up, Bastion? How you doing, bro? I'm doing great. Are you close to finishing your compiler? Not even close. Still have to do the middle end here, which I'm doing right now, and then also the back end. So, not even close. Okay. So now when we have a value that we put in a register, in a virtual register, we increment by 1. And depending on the entire quad that we have, we push back that specific quad that we have onto our vector of instructions that we have. And okay, what else do we need? It's great, Bastion. How's the monitor going, bro? I know you got like a new monitor or something. I'm actually learning something called Helix, an IDE for Helix. Helix motions are there. That's what I'm trying to learn right now. Oh yeah, it's a 4K monitor, dude. That's nice, man. Alright, I think that's it for the private members. I think now we just need to, well, I'll probably add some more later. I'm sure this is not the only stuff we need, but we need to walk each of these functions right here. Okay, so yeah, let's just implement one by one. Let's just try and implement what we can. So we'll say we're gonna want to override what we have already, so I think that should be good. Let's just start with, oops, not like that. Let's just start with this one, to be honest. Let's just start trying to implement this one. We'll add the rest as we go. Alright, so our generator. Okay. My config is like 1900 lines, custom plugin management Rust, and custom Git for it. That's what I've seen people not like NVim so much, UVim so much for, the amount of configuration you need. So some people suggested that Helix was a good option since it's just built-in configs itself. Should I make a project social website so you can comment and show projects, or show what type of code language you're working on, share projects to people? I mean, GitHub exists for that though. And I'm sure something else probably might exist. as well. Oh yeah, lazy-v is also one of them too. Yeah, Helix is written in Rust, I'm pretty sure. You started to appear on my YouTube For You page? That's amazing. It's amazing. Alright, okay. So for this one, right, we have a binary op node, so we're gonna have two. So we're gonna have, let me go back here, we're gonna have, let's just map out. We have two operands. So we're operating on two operands. And we're gonna have one operator. And we're likely gonna be storing that in, storing each of these values in destination in a register. The end result we're going to be storing into a virtual register. So we'll say result stored into virtual register. And we'll probably say both of these operands will be, I mean, I guess they could be immediate values. Let's do like an example, right? So we have like 1 + 2 × 3, right? Okay, this is probably how I'm going to see it. We're probably going to have okay, let me probably do it in Paint. It might be easier to map it out in here. Alright, so okay, so what did we have? We had, I believe, 1 + 2 × 3. Our parser should be creating the tree like so. Let me just write out the tree. It should be creating the tree like so. So it's gonna be, yeah, so it's gonna be this one here. It's gonna be the multiplication operator here. Let's just pretend that's the, yeah, operator. Terrible drawing, but that's okay. And then it's gonna do this. So this is the tree structure that we have. And likely we're gonna be having, I do want to test this. After we write this, I want to test it. So we're probably gonna have the output be something along the lines of like, okay, these are all gonna be immediate values. So we're probably gonna have virtual register 1. We're probably gonna say like load immediate or something, because those are immediate values. The value of 2 first, the value of 2. We'll say v2. And I'll also do this one. Load immediate 3. Let me expand this out so it's all in one line. Alright. Alright, then it walks up to this one, which will sound v3. And that will be the multiplication operator. And it's doing multiplication on v1 and v2. So probably say something like that. v4 should do 1. So say load immediate. And say 1, and we'll likely do v5 as it goes back up the tree as our add operator. And it's adding v4 and our v3 value. Something along the lines of this should be how it should be printed out when we test it out. This is what I'm probably gonna go for. So yeah, it start with this one first, right? It'll start with the 2 × 3. So we do need to grab our 2 children values. So I guess we could say I believe the syntax for that was, I was somewhere, yeah, it should be something like this. Grabbing our 2 children that we have. So the left node and the right node. So the left node would be our 2, right node would be our 3 value. And we just want to grab this, but not, I mean, I guess, yeah. not necessarily accept though, right? Or would it be? So we have that, and we likely want, we're gonna need our operand as well. Do we have a way of writing the operand, the operator, sorry, not the operand, the operator? Maybe make a map of our different operators. Probably might be best to do that. Probably make like a, or maybe even just a switch case statement. We can have like a function where it takes our operator and then goes through the cases and sees which one it maps to. Yeah, that's probably best. Okay, to operands, operator, results stored into virtual register. Okay, yeah, we do need to allocate our registers, so we need our destination register that will be stored in. So, something like, let me just go down here. Let's say like v. Basically like our destination register, and setting those two values, the two child nodes that we got, and we already do have that function, so we can probably say int dest register or something like that. Well, let's make it simple, dest reg, and we'll say we just want to call the function allocate register likely. That's likely how we do it. Okay. We're going to want, okay, we're gonna want our switch case statement. So let's go back. Should we do it in here? Probably, yeah. We'll probably set like a function. We'll probably say ir op maybe. I guess we could call it like map token type. Basically or let's say map operator. That'll be better. Map operator. And it's gonna be taking in our op value. Let's see. It should just be taking our operator, right? So what should we exactly have that we take in? Yeah, I guess just the operator itself. So we'll say, like in here, we'll probably just say likely, something like that. Oh, okay. Let's try and implement that in here. So we'll set a forward declaration. Let's try and implement that in here, like we did. Our generator. Okay. Well, what exactly are we? Well, that wouldn't make any sense though. Hey, what's up, Swan? How you doing, bro? Damn, I'm really bad at this. It's showing right now. Really bad at thinking this through right now. You're not too late. You're not too late. Well, we just want to make the operator, right? So we probably don't, not the operator itself, we probably just want to say our token type and map that out. So in here, we'll say token type. We want to just create values for what we had. So back in our ir.h, we just implemented these. We're just going to implement these. So we'll probably say switch type based on the type that we're given. We'll say case token type plus and what are we exactly gonna? We're gonna return the ir op that we have. So we're gonna say return ir op and set the value as our add. I believe we just call it add. I believe. So that should be good. Yeah, that should be good, I think. And probably the same exact thing for everything else that we did. So let's say case token type. We'll do minus subtract oh yeah, that's right. That's what was wrong. I was seeing for a second what's wrong there. Yeah, that's right. Appreciate that, Max. Welcome to the stream. Appreciate that reminder. I totally forgot there for a second. Case. I just said null, right, for that. Or what did I say? I just said null. Oh no, for this it'll be multiply. What did I do in the lecture? It was Let me see again. Oh, star. Okay, yeah, I remember now. Star, and this should be one. Yeah, that should be good. And then we'll do. It's 11:30 p.m. there on vacation. Dang, man. It's 11:30 p.m. here too. Slash, I believe, and then div. Okay, these 4 cases for now. We'll add more as we go. And okay. Now we want here. We want our specific operator to be returned here, so we'll set up and we'll set that as, we'll check the we'll set the value that we need, and it should be our, what exactly are we going to take? Just the op value, I guess. Probably right. No. What exactly? Should just be op, right? But we don't have that. Getting a bit confused here between the types and stuff. Okay, just end that up, yeah. That doesn't work either. Right, okay, I see. Yeah, we're taking in a type, right? Alright, yeah. Okay, so now we have our 2 child nodes set up. We have the destination register. We have our operator to set that up. So now we just want to basically emit this quad that we have. So we'll say emit function. Okay. But we need the quad itself. not gonna lie, this is definitely a skill up from, definitely a level up from the parser, not gonna lie. Hopefully we will pick up pace as we go on, but starting off slow, but that's okay, I guess. Alright, wait, so okay, so we're gonna need our specific quad that we have. We do have our quad build, so what's up, Agent Brady? Yeah, I'm getting stuck on this just because of the, like, how the visor pattern is and everything. It's kind of hard to visualize this properly, but hopefully we can pick it up. Definitely the Lexer and the parser was way easier to write. It was way more intuitive. I mean, I guess we can just create the quad inside itself, right? Probably. I assume. So I can say like, so how do we initialize? So we have the quad itself. So let me take a look. Okay. Destination source register, source one operator, so operand, our operand that we have. I want to set if I don't get it soon, I might just ask AI about the mid function, how to actually pass that properly. Yeah, let's just do that. I don't think I can figure this one part out here. How to actually pass it in properly. But after that part, then we should be able to write tests. We should be able to write one test out the binary operator to see how we did, the binary op node. I'm gonna try to test more often during this stage, especially since we're struggling a lot, so we need to probably test more. Just gotta make sure you don't offload your mental onto the AI. Yeah, that's true. I did give it some thought though, I can't seem to figure it out. Generator H, that was that one, and then hire.h. Emit function. Hopefully it just gives me the emit part and not everything else. Okay, wait. Alright, let's see, wait. So we have the basic parts correct so far. You have some sort of reference for how to implement stuff. I just like basically read the book, watch some random YouTube videos about the topic itself, and just write some Obsidian notes, kind of design it. Sometimes I talk to AI as well to understand how modern compilers are built, because some of the books are very old into how the implementation is. Alright, wait, so... Okay, so it's just building the quad up. It's just building the quad up with its different types that it has, okay. Looks like we did the part properly though. Yeah. The book that I was reading was like written before like vectors were even there. So it kept saying to do either an array or a linked list, but now since we have vectors, we can just easily do that part. Okay. Yeah, okay. That's what I was getting wrong. So we need to actually make up the quad itself. We need to build up the struct. So we need to say and set each of the values within it, I guess. I guess. So was it like that? Oh, not this one, sorry. It's quad.test. And set it up for each one. And set each type. So we have our operand. Our operand is based off our type and also an int value. So we want to say what our type is. So a destination register would just be a virtual register. It would essentially just be a virtual register that we have. A quad is essentially just this, our 3 address code. Each element of our 3 address code here makes up the quad that we have, and it's very similar to how risc-v assembly looks. So that's what we're essentially building up right now. Okay. Quad.test. I guess. Okay, so it's going to be a virtual register type. So we're going to have, I believe you put it in curly braces like that. And we have our operand type. Our operand type is a virtual register, I believe. And then also our int value that we set. What exactly, do we just increment by 1 for each value? Or destination register. Oh, you talk to risc-v people, interesting. It's very interesting. Our value, okay, wait. Oh, okay, okay. No, I see. That makes sense, I see why. And we're taking source 1. Essentially the same thing. That's going to be an immediate value, I believe, since it's just the value itself. It should be the 2 value in our case. And we're gonna be taking, I guess, what do they put? Like just the value that we have? Yeah, okay. Okay, we should probably store it into a register. That's what we didn't do in here. That's what we forgot to do. That's probably better. We weren't too far off though with this upper part. We just forgot a couple things. Okay. And okay, so this is gonna be operate type. Same thing as before, it's just gonna be the right branch. Hopefully after we do this node and we test it out, hopefully we can do the other nodes faster since we know how to actually do it now. And then we also want our quad.op, I believe. Well, that's not really operand type. I guess we would just say none, maybe? I guess we just say none. Most likely. And then op. Let's see, wait. Oh, that's where I went wrong, yeah. The operand op is not an operand, yeah, sorry. That's not right. That's not right. We just said that as op. So, and what went wrong here? Value type void. Something go wrong in our visitor. Oh, okay, wait. Well, that shouldn't affect that though. That shouldn't affect that. No, that's fine. These need to be int though. Int. Int. Whichever 0. But what's going wrong there? I'm not exactly sure. It's a value type void though. How will you handle the equivalent of CRT 0? A CRT. What exactly is that? What is that CRT? Damn, we're actually running into a lot of problems. This is making me hate the visitor pattern more. And then okay, in here it's just a mid quad, right? Alright, what is now? What is it because these? Oh wait, no, they are int. Do represent the right type. Oh, wait. Is it because of this? Well, no, this should be void, right? thought it should be. If I change it to int, I doubt it'd work. No, it wouldn't. So, wait. I don't understand why. I don't understand why. Okay, we'll add that in a second. Okay, let's give it the error. I don't know where it's actually wrong. They're all ints here. They're correct within the other visitor in our AST printer as well. I hope this is not where it gets too hard for me, where I end up having to quit for a while. I hope not. Hopefully I can pick it up here, see what's the problem, figure out for the rest. No, I believe I did change it to an int though. Or wait, that's a different one. What's in here? Oh, in our AST file, yeah. Oh, do we not have it as? Oh, okay. I didn't realize these were all void. Maybe I forgot to change that earlier, but. So in our main one, okay, so our main one has to be an int here, and then every single other one can be int, okay. I guess I forgot to change that, and I didn't realize it would cause problems later. We need to do that for every single one here. We should all be returning ints. Okay. Alright, now we're fine, okay. Well, that was a long process, and we should just be returning our destination register, I believe. Okay. I mean, that should be good. I guess we can kind of start implementing our other ones. Unary node. Let's add that into the file here. Okay. Alright, let's kind of think how we need to do that, do this. Okay. Alright, let's see the pattern. So for this one, it's just gonna have This one is just gonna have one operator, and it's also gonna have literal value, I guess. That's how it should be in our thing. Yeah, just the operand that it's operating on, the literal value, whatever it is. Let's say operand better. And okay, so we likely won't need, we'll probably just need one child that we need to take. Right? So we'll probably say it's only one child, might as well just child reg. That to be n. It should just be the variable here, so n dot operand. Just like how we did earlier, so n dot operand. We want to accept. Yes, this should be good. So now we are taking in our one child node that we have for our operand. And now for the operator, it should just be the same. But okay, it's gonna be a different. Okay, operands, the operators that are acceptable for this would be, we only have two unitaries so far, which will be not equal to, not and we do have minus as well. I believe I implemented minus. So okay, so we may check that. Should I look at the table though? Should I look at the table for this? Okay, we can probably do that. We'll probably set them in the table and probably do something along those lines. So let's go back up to the table. We'll add a new case. Well, no, the thing is though, my minus case was handled separately, so we probably don't want to do the table. Probably don't want to do the switch case statement, so we'll probably just check it itself here. Maybe like if r n dot op type, and essentially we just want to do something similar to how we did up here. Just check the token type of what it is, but just not checking the table itself for the unary. So token type not plus, but we want to check if it's either. We want to check if it's the exclamation mark. And okay, we probably want to set a new value. Or actually, wait, I did want to test this. Wait, I wanted to test this before we move on. Maybe we'll put this on a hold for a second and test out what's going on there. I did want to test out first, so okay, how can we possibly test this out? So this is taking in, okay, this is our binary op node, so we're taking in a couple of values and operating on that based off the operator. So we're going to need to grab our operator and also our other values. Okay, let me try thinking this out real quick. I guess we can add some helper functions in here to try and get that in. We kind of just want to test it out just like how we did with the parser here. We just wanted to test this out and check, but just instead of the parser, we're checking out the IR generator's output. So we need to somehow do that properly. So let's go back. How might we do that? I kind of want the output to be something like this, just like how he said. So we need to grab our values based off what we're setting them into the register as, and we're printing that out. So we're printing the virtual register name that we're on, equal sign, whatever value it is, whether it's immediate, multiplication, adding, any type of operation we're doing. So I guess we can make a function, possibly, right? We can just say like print IR, and then implement that in after. Okay, let's see if we can try and implement that in here. Let's just come it up here, or let's do down here. That would be the end, right? So let's just say, let's bring that over. What do we need to make this work though? Is what I'm trying to think about. Okay, we just want to probably go through. Well, okay. Let me see how this was. So we just added it to the vector, right? So it should be in the instructions vector, right? So if, let's say, if we're in the REPL and we add some like value, some expression, it should be in there. So I guess we just loop through it, maybe loop through. I guess just loop through that instructions, I guess. So let's say auto, and I guess we're looping through the quad. So it's a quad instructions Okay, and then okay, so what exactly we're checking? So we want our destination register first, like we want it. So and I guess quad.dest. Oh, is this because okay? I think I've encountered this before. We need we've encountered this before multiple times actually. We need to create a mapping of each of these. So we need like a function that basically has a switch case statement to actually map the values to actually return something, so we can actually print this out properly. Okay. I guess we could say operand. Yeah, we just need, it's kind of just like how we needed, I believe it was back here. Yeah, we need a toString function so we can actually return our value properly. So same thing here. We can just implement it in here. We can say we'll say operand to string. Basically taking in our IROP that we had back here. Or no, it should be not IROP. That's for operator. For us, it would just be, I guess, just operand, our operand value that we're taking. Operand, we'll say, yeah, that's fine. Slowly but surely we're going through this. I guess we can implement that. We can implement that up here. Not a problem. I could say switch operator type. And there's only a couple of types that we have. Right, we're returning our, in this case we're returning our vreg, and in these two cases we're returning immediate values. So we want to say, for the case of, I believe operand type, yeah, operand type, virtual register, let's see, what do we want? What do we want though? We wanted to print out v and our value that we have. So the virtual register value. So let's say return v and I guess just the value itself that we have, the value, the second value that we have. So we want to say v plus I believe it's not a string, so we need to convert that. operand dot value that we have, that we set, the value that we have. That should work. So that would give us whatever value that we have appended with the v prefix to signify it's a virtual register. So that should be for our destination register. And now for immediate cases. So we can say case operand type immediate. Same, basically same thing, to be honest. It's the same thing. I'd assume it's the same thing. So I guess, wait, so... Well, no, it's not the same thing. Our immediate value is not going to have a register. It's only going to have a temporary register, but it won't be in an actual. So we'll just probably just say that. Just our valued stuff that we want to see. What else? We do have two more cases, I believe. Label and none. How should we handle those? Oh, yeah, it's out there. I mean, I guess with this we can probably append like the prefix L or something to indicate that we're having a label. Like L. And I guess just that, right? And last case we have is going to be, I didn't need to copy that. Okay. I keep forgetting, bro. It has to be, I don't know how I'm getting that outside of it. Okay, no. We don't really need to return much for that. What's a default case that we can have? Return operand to string failure or something, just so we know that it's in here if we ever get that output. Yeah, appreciate it. Harmish, appreciate it, man. Kind of slow right now, but we're trying to do what we can. It's definitely getting pretty difficult, not gonna lie. I assume the back end's gonna be a nightmare for me, but hopefully I get better by then and I can actually like work my way through things properly, way better. Okay, operand to string failure. Okay, so that's good. We have covered all the cases. We also want to have one for want to have one for operator to string too, because we're going to need the operator too. Operator to string. And okay, that should be good. Now let's implement that in here. Okay, what exactly though? Okay, so we're gonna take a switch on the operand, obviously. Oh wait, it's not gonna be operand. It's gonna be IR op for this one. Let me go back and change that. I forgot to change the parameter. It's gonna be an IR op. So we're gonna essentially be looking at our value inside IR op and take that accordingly. So we'll just return that. This is just returning the string value that we have, that we need. So this is pretty intuitive itself. We just want to get the same values that we have. I really need to learn, like, I am learning currently some IDE that has like motions, like fin motions, but I'm learning Helix for Helix motions, so I can actually get faster writing this stuff. I can tell it takes a long process just to like change some values. But it should get better once I learn that. The evil editor, what's wrong about Helix? A lot of people said that Helix was better because it has, not better, but it's just easier for people who just want to get into the config, because it's like a built-in config. You don't need to make your own. So yeah, it's like the same. People said like a pain point was making the config for U of M. Yeah, I'm pretty sure it's like, I forgot exactly what it is. I just started yesterday. I think it's like verb object or something, and U of M is like object verb, or it's probably the other way around, something like that. Okay, this should be fine. Okay, now we can actually access now. So for the case of this, it's been a week or so using only motions in your power up. Yeah, it might take a bit longer than that, but yeah, probably. I want to practice every day. Like my random coding tasks that I do throughout the day when I'm not streaming. I think it'd be too hard to stream this and motions and doing motions, because I have to think even extra for that. I'm already struggling with the IR right now, so that'd be a pain. You also filter everything. What's up, man? Welcome to the stream. Alright. Okay. We have prints. Okay, so we have both so far we have the ones that we have so far for operator string and operator to string. So let's try and print out what exactly we want. So F1 query, I'm planning to learn C++. Can you suggest some books and from where I can learn new courses? You can learn from learncpp.com. It has like everything. But I would also just recommend just maybe watching some YouTube videos or maybe finding another C++ book, because this is kind of slow. So if you're kind of a slow reader, you're not quick to absorb information, this might take a long time to even get to something as basic as pointers. So I'd probably recommend just going over basics of stuff and then going over nuances as you go. What's up, iDrag? I can't pronounce that name properly, but what's up, man? What does this do? This basically is a compiler. I'm basically taking a subset of C and compiling it through to my risc-v emulator that I wrote over here. That was the previous project I did. And now we're on the compiler. Right now we're on the intermediate representation. I will say, emulator is so much easier compared to this. I was actually breezing through the emulator, but now this is like, you have to think so much more for this. Okay. Okay. Let's basically map out what we need here. So yeah, so we wanted our destination register, right? We also wanted to have our other values as well. Okay, so what's the way? So go to test type or no? Well, yeah, no, it's right. Quad desktop type. And essentially, we just want to check. Or no, we can just print that. Well, no, that's not right. Just calling our function probably. This is going to be our operand, right? Operand for the register. Operand toString. And okay, here it's quad.test. Yeah, I remember now. Yeah. And yeah, that should be fine. So that value first. Let's give like a little space there. And okay, yeah, we'll add a little space there and then you line it. I still know a lot of people say C++ is bad, but it's fun, you know. It's pretty fun, except at times like these where you get really confused about language features, especially if you're new. Like, I only started like a couple months ago, so maybe this project was too big for me to take on right now. But yeah, I thought I was doing fine because emulator, I breezed through that. Parser and lecture was pretty good. I'm getting some friction here, but hopefully I can work around that. Maybe I'll ramp up as I do this more, as I do more of the IR. Also hate doing header files. Yeah, I don't like header files either. Like the way you use them. Yeah, C++ has a lot of bad in it, yeah. Unfortunately, it's still very much industry standard for systems programming, so I might eventually switch to the language later, but at least getting this one done in C++ so I have something to put as an experience. Yeah. But I feel like C++ has a lot of extensions on top of random computer science topics. Like, it's not just the computer science concepts. You have a lot of extra stuff that they added in that you need to learn. Yeah, then you don't get to pick and choose which features you get to interact with. Yeah, I'm pretty sure, like, I hear a lot of people like still work with older versions. Like most people work with like C++ 11 or 14. in the workplace, so they don't have a lot of the features. So they wouldn't have like the string view, which was introduced in C++ 17, and a couple other features. And people working with C++ 11 won't have make unique. I think make unique was C++ 14, I think. Oh yeah, template metaprogramming, yeah. Okay. This, then we also want I'll probably dive into a new language next year after I get better with this C++ stuff. Oh yeah, we probably want to say we probably want to say equal. Yeah. Let's do that, yeah. So it can show that we're setting that value equal. Okay, so getting that destination register equal. So next, I guess, would be the next value, the next operand value. So we want to probably say well, no, we don't need equal here. Sorry, wait. Our values, this is how our thing's gonna go. So, or I guess I included it there, but we don't really need it though. Virtual register, operator, and then whatever we're operating on. So we could say operator. What did I call it? What did I call that function up here? Operator to string, yeah, okay. I didn't know if I did op to string or operator to string. So operator to string. And quad. We want to grab our op. We want to grab our op value from the quad. And we can say that. And same thing. Just add a space. And do that. Then we also do want our values. So let's say, what do we call them? Source 1, source 2. Source 1. Source 2. Well, actually, wait, we don't want a new line. What am I thinking? We want them all to be on the same line so we can see properly. Okay. I think that should be just for a generic test. I hope this works. Because I know last time I had some difficulties with testing. Also, build systems are absolute garbage. Yeah, CMake is, yeah, I don't really like it. But it's necessary to know. Okay. Is that it? I believe so. I believe so. I believe that should be fine. Okay, this can't be the ASC printer though. We want it to be the, we don't want to put the AST anymore. It's called power generator. Or what is the, oh wait, did I write it wrong? Did I write it wrong? Oh wait, no, we didn't include, that's why. Let's just include it. H. IR generator .h. That should work now. Our generator, let's call it I guess just IR generator. Or IR gen, we'll call it IR gen. Here that's fine, but we don't want it to be printer though. Because that's for the AST printer. We want it to be print IR, I guess? No, not that. Well, it's just gonna be IR gen. Likely. I don't know what's wrong there though. Okay, but here we want to now call the print.ir function. And we have a problem with C++ again. I don't know what's wrong here. There's always something going wrong. I don't know why. Alright, wait. Object of abstract class. There's no. Okay, wait. CMake BS is where I call the LLMs. Yeah, that's true. That's true. Alright, what's wrong? I mean, I said has no overrider. Oh, I see. Okay. It's because we didn't. Okay, yeah. We should put all the functions here. I'm guessing. I'm not sure though. I'm not exactly sure, but I think we'll do that. So we want to visit each function, I guess, to say. Let's see if that actually removes that one error. If not, then we have to consult our good old friend, because I do not know. So if we override it here, does that print that error away for that? It does. Okay, so we just need to do that for each one. I have no idea why, but yeah, let's just do that for each one. I don't know why it won't just work without that. Alright, they're all gonna be in 0 to age. Let's just grab them each. So we did literal, and we need identifier node now. We'll just grab them as we go. So override for each one. Then after, I think we are able to test it out, hopefully. And hope that our output is right and it's not bad. And then I probably might end stream. I thought we'd get much farther, but I guess not. Grab each of these. Put them in. Now this is where I probably think like Helix would be nice. I can probably just replace all of these at the same time. Like very, very easily. Okay, now it should not be complaining anymore. Ideally. I think we have everything we need, right? Okay. I think we are good there. What should we test exactly though? I wonder what we can test. Let's see if it even runs. No. Seem to have a lot of errors now. Our ast.h. Looks like our ast.h has some problems. What did we... Why? It's at age 29. Okay. Function, overload function differs only by return type from that. Okay. Wait. We shouldn't have a vertical keyword on these anyways. So I don't know if that's the exact problem, but it looks like there's probably something else though. Let me comment this out for now. We should probably get rid of all these. I don't actually know how to get rid of all of them like at once because it's highlighting all, but I don't know how to actually do that on here on Visual Studio. So I guess we'll just delete them all, just one by one. It's not that much, so that's fine. I don't think that's the only problem though. I think there's still gonna be errors, but it's less than before, but there's still a couple left. That's the problem I'm not understanding. Overload function differs only by return type and our okay, visitor.tpp4, let's take a look. I want to try and figure this out by myself, but let's see. Okay, yeah. Alright. I'm gonna change those. I didn't realize I forgot to change them here too. Okay, well, at least we didn't use AI to figure it out this time. That's a step forward. I think that should literally be the only thing, right? No, there's still a problem. Let's see, visitor CPP for each one. Okay, but now we need to return a value. I guess we'll just return 0, I guess, right? We can likely just return 0 for each. How did I do that in here? Yeah, just return 0. Probably just see if that works out. See if that works out for these. No, still problems. Okay, let's see. Okay, now we have linker errors. Wow. Okay. It's like one thing after another. Our generator is a func call. main does it be? Okay, wait. No, that's just the object. Okay, I understand. But where would... So that should be in our... Oh, okay. We didn't... Okay, this is why we didn't implement all of these. At least put them in. We didn't put them in. Okay. I will put them in. I will just come these parts out though. We just won't implement it here. Your C++ code is honestly fancier than mine. I'm super utilitarian with how I code. I don't type comments almost at all unless I'm tweaking out, which is not very helpful. Yeah. I started writing comments just to like be able to map things out myself so I can understand what I'm trying to do. It helps for the most part. Not in these situations though, when you have language errors. Not inside here. When you have language errors, that's up to you to just figure out what's going wrong. Okay. I really hope there's no more errors after this. I feel like I've been saying that forever though. Generator. We'll just add that namespace to each one. Separate out functions. I guess this is fine because now we don't have to do this later on. We'll have them all set up. Man, I just want to test. I just want to test one piece of code out, and now they're making me write everything here. Okay. Very interesting. Okay, looks like everything's good. Did I miss any? Why is it not still? Looks like it's still not picking it up for some reason. Do you need like an implementation or something? No, okay. It was just delayed. Alright, please work. Hopefully. No, it does not work. Alright, what's wrong now? Oh, they want to... Oh yeah, we need a return value. Okay, for these. I guess I'll just return 0 for all of them. For now. Okay. Quite a lot of things I have to do just to get one simple test out. Well, not for the boy one, sorry. Okay, at least something opened up this time. We do have some errors though. I will take a look at those probably. Okay, those... Maybe I just didn't return for everything. As long as you have the willpower to like start a project that feels hard or very hard, you'll eventually see a result and feel very satisfied. Yeah, I started this, I understand that I started this emulator project. It was a big project at first, but it was pretty nice for me to see the results that I coded. I'm just at a point now where like the code base is kind of huge, so it's like I'm kind of struggling to navigate it properly, but I guess we're trying. So I guess we can probably test out like something like, I mean, I guess if we say like 1 plus 3, just as like an expression. Well, no, it's not printing out anything yet. So something is definitely wrong. It should be printing out our values that we need. Let's see. Yeah, I might have some crazy memory bug, yeah. Probably. The parser was working fine. Now I started writing the IR, so now there's a lot of things I probably either wrote wrong or just wrote bad. That's not working, so okay. Let's see. In our IR generator, there's P, line 72, or line 72. On reference parameter. Our system of Zig is really fancy though, is it? I haven't looked into Zig that much, so I'm not sure about Zig. Wait. I tend to see this error a lot. I don't... On reference parameter, what does that? Got that for all the errors down here, but well, I guess that shouldn't be interfering with this, but maybe... I do want to get this figured out before I leave, though. Hopefully tomorrow will be much smoother, because today we figured out all the issues that could have happened, so tomorrow should be much smoother. Well, I might not stream tomorrow, though. Maybe day after tomorrow. Tomorrow or day after tomorrow. Something like that. Okay, I think I know why. Because we wrote an expression, right? We wrote an expression, but we haven't wrote expression statement. Or wait, no, wait. That shouldn't... I mean, that shouldn't really... Should that affect it? I guess maybe it could affect it. Okay, if we need to implement this, I might end the stream. If we need to implement this, and probably do that tomorrow. I'll probably implement this first thing tomorrow. If that is like the thing that's blocking our thing. I mean, how hard would this be? What exactly do we need? Use cloud code? I feel like I wouldn't get anywhere with that though. I'd just be passing it to that to do all the work. I wouldn't really get anywhere with that. I need to at least have a fundamental at least, but okay. What is the problem? So visit XPR. Let's see, like the implementation. If it's easy, then I might do it just quickly. Let's see. I mean, it's just one expression, right? It's just that one expression part, so we don't need any child nodes or anything like that. Like it's just a looping switch statement that recalls itself and exhausts all cases into enums and stuff, but it's really fun to code in, but you should not probably code in Zig if you're willing to not use almost any external libraries. Interesting. Zig is on my radar for the next language I might learn. It's on my radar. There's like 3 languages on my radar right now. Rust, Zig, and Odin. I have to research more though about each of them. Okay, so there shouldn't be any child nodes here. We're just taking the one expression that we have. So it's gonna be way simpler than the other ones. And it's just gonna be a statement, so we're not really returning anything, we're not returning anything, we're just passing through. It's just the behavior that we have here. It's not returning a value or anything. It's just telling the parser that it's an expression that we went through. So I mean, I guess just this, right? It's literally just this. And if you have this, I guess it's fine, right? We're not returning anything, so it's fine. We're not really adding anything. Let me see. Let me see if this works. So if we have okay, we at least have some output to work with now. So we have virtual register 1, so it looks like that part's fine. We have the add instruction, so it's able to accurately determine that it's add, but this part is wrong. And also, okay, the REPL line is not new line. I need to add a new line here. 0, 0. Let me take a look back. We're getting somewhere there. We're getting somewhere. Let me take a look back at the. So we had our example was 1 plus 2, right? So we needed to put quad.source1 operand 2 string. Let me take a look. Operand 2 string. It should just be the operand value itself, but we got 0, but it's supposed to be 1 and 2 though. Coding with a friend is nice too. I've never done that before. Odin looks compelling. After learning Rust, I've been looking into Zig. Good luck with Zig. Good luck with Zig. I know you have a lot of projects lined up, AJ Brady, for the summer. Our operand.type, so we have that, and we have okay. It should just return the value. Maybe something's going wrong within the function itself. Left reg. No, I don't know him. Just from previous stream, he told me some ideas that he had, but what he's doing. He showed me one of his applications that he made. Hey, what's up, Scottish? How you doing, bro? Okay, I'm not sure exactly what's going on with the immediate value. It should be. Okay, wait. And left except. So that should be. I mean, it should be returning the values, but I'm not exactly sure why. These 2 parts are going right. We know this part is fine. Stretch. Look. not exactly sure. I might ask about this part. Is it just because we're not taking the... No, we are taking the value, though. We are taking the value. What on source 1? Source 1 should just take our... 6:03 a.m. Bro, you gotta go to sleep, bro. Unless you're not in Scotland, but yeah. Seems like you are. So... It's pretty late over there, man. I'm not exactly sure what's going wrong. I know we're so close. We're so close. It's just not outputting the right values here. 8 a.m. in Egypt. 8 a.m. in Egypt? Oh, you're in Egypt, man? That's nice. Very interesting. Okay, wait. App operator and .op.type. So that's taking that, yeah. It's 1 a.m. for me right now. I'm probably missing something very, very simple. I need to take a look, though. Let's get plot what I did so far. With the main as well. Avoid one. I think, yeah, let me... REPL output is the virtual register is right, and so is the operator, but not the operands, not the, I guess I'll just call it source 1 and source 2, because those are technically the source 1 and source 2 registers for risc-v. I don't know what's going on though. Let's see. My accent sounds mid-England. Dang. Nah, it's just a random American here. Why return 0 instead of actually allocating a virtual register and loading the literal value into it? Yeah, I'm in Florida right now. Okay. I gave the type wrong, but it's going to be an source 1 is an immediate value. Oh. Okay, right. Okay, that makes sense. Because our literal node value is what we have for our immediate values, so we haven't implemented that yet. That's why it's not working. If once we implement that function there, then we get that. Okay, that makes sense. That makes sense to me. Okay, but that seems to be fine then. Looks like if that's the only problem, that means that our output's actually correct. After a long time, we actually managed to get that. So I guess tomorrow we'll see more of the implementation for that. Let me just change a couple more things here, and I might end the stream soon. Very soon. Yeah, I need to add a new line here, so it gives the REPL line a new line. I guess it'd be the same if we said like x plus y or something. It'd just be one add 0, 0. Let's try x times 2 v1 mole. Yeah, that was good. X minus 4 x minus x /0. And our parser caught the error there, so that's good. Seems like everything's working fine, as expected. Well, we can't divide by 0, so I need to add a divide by 0 case at some point. Yeah, everything seems to be fine with the cases. Looks like we actually got somewhere today, so that's pretty good. Yeah, I did Python first, yeah. Last year Python. C++ is relatively new for me, but I'm enjoying it so far though. Potential expensive copy. Okay, let's do const auto reference. That should be fine now, right? Yeah, that's fine. Totally forgot about that. It is 1:09 a.m. I might end the stream right now. It was a pretty good session, I'm not gonna lie. We did have a lot of trouble at first, but we seemed to figure it out. Especially at the end, we didn't really need too much help. So that's pretty good. Tomorrow I assume we'll probably get to the next functions. Like, upload all the other expression statement functions, and then also now the regular statement functions. I don't know if we'll get all of them, but we'll likely get some of them. So yeah, that's tomorrow's agenda, and I think we've had a pretty good stream today. We had a couple people join in. Agent Brady, Eslo, I Drag, Ghost, Max, Scottish, Bastion, Isrith, Swan, and a couple other people. So yeah, I hope you guys enjoy your day, or enjoy your night, wherever you're from. And yeah, I'll see you guys next time.